Hello, welcome to Cloud Native Live, where we dive into the code behind Cloud Native. I'm so excited to be here with you this morning. I'm your host today. My name is Whitney Lee, and I'm a CNCF ambassador. Every week, we bring new presenters to showcase how to work with cloud native technologies. We will build things, we'll break things, and we'll answer your questions. This week, we have Alex Olivier here with us to talk about Beyond the Black Box. So, we're going to go over implementing robust authorization in RAG based AI systems. So, this is an official live stream of the CNCF, and as such, it's subject to the CNCF Code of Conduct. So please be respectful of everyone else in chat. Be respectful to Alex. And if you want to be nice to me too, I'd appreciate that. So friends who are joining us live, please do say hi in the chat and say where you're tuning in from. I absolutely love how we're part of a global community. And if you have any questions during the presentation, please put those in chat too, and we'll answer those as we go. So with that, I'll hand it over to Alex to introduce himself.
Great.
Alex, take it away.
Thank you very much, Whitney. Hello, everyone. Good morning, afternoon, evening. Insert time zone appropriate salutation here. Very happy to be here, and thanks, Whitney, for setting this up. Today, as Whitney said, we're going to be talking a bit about kind of what we need to think about beyond just setting up a fancy LLM or AI system. Like, what are the bits you need to really consider around production as those things? And we're going to look at particularly through the lens of authorization. So, by way of quick introductions, I'm Alex Olivier. I am, apologies, I'm a software engineer at heart that has turned into the dark side of product in recent years, but built my career initially at Microsoft doing kind of consulting on data platforms for banks and like health medical companies, and then moved into the world of SaaS startups. So spent 10 years building systems in MarTech, e-commerce, supply chain, and various other industries, but always very much focused on what at the time was like data and DevOps and infrastructure, and now kind of looking more broadly at kind of some of the themes that I saw across those businesses, have now working on Cerbos, which is an open source project which solves one of the common challenges I had to keep building across these businesses, which is around authorization and security, which is what we're going to be talking about today. And because it is 2024, late 2024, we have to obviously talk about AI and LLMs. And this is something I've had to learn myself over the last 6 months or so, and going to kind of run through what a basic RAG model is and how that all works, and then also applying a security lens on top of it through a mixture of slides and some demos. If you want to find me, you can hit that link or go to the QR code for various different pointers to resources we're going to be talking about today. So just to kick it off, frame the conversation firstly around kind of what is this authorization thing, and then we'll go on to the RAG side of things. So authorization is the number one issue as reported by OWASP top 10 in multiple reports now, which ultimately manifests itself in broken access controls. Users being able to do things inside of your systems, inside of your applications, that they shouldn't be able to do. And one thing about this word authorization that really annoys me is it sounds very similar to authentication. Particularly as an industry, we like talking about auth-N and auth-C, and they are
Preach.
Yeah, they are very, very different things. The best way I kind of describe it is authentication. It is challenging a user to provide a credential that proves who they are. So, I'll say to Whitney, give me your username and password. I'll verify that username password, issue an identity. Cool, we now know who you are. It's the equivalent of like you have a passport, you go up, they verify your passport is your photo, that's you, cool. And then the authorization side of things is, right, we now know you're Whitney, what can you do inside of this system? Based on who you are, what you're trying to access, should you be able to submit a report, edit an expense, view an invoice, all those kind of actions that are very contextual based on both your identity, but also the resources of who you are. And to use the travel analogy further, we now this use you in the passport, but the border officer has to decide whether you're allowed in the country or not based on visas and those sort of things. So that's kind of the analogy there. So we're not going to be talking about authentication. We're assuming this is a solved problem. There's standards out there now, OAuth 2, OpenID Connect. There's some great off-the-shelf open source IDPs like Keycloak in the CNCF ecosystem, which do authentication really well. You shouldn't go and build one of those. You should go and stick one of those inside of the systems. But the next step is authorization. Now you've got this trusted identity. What can you actually do? What should you be able to access inside of a particular system? The other reason why I think authorization gets a bit confused is the HTTP spec is wrong, if you ask me. Back when the original HTTP spec was built or defined, there was an agreement of let's put an authorization header in there, and in that authorization header, you provide some sort of credential. That is authentication in my view, not authorization. So even back in, I think it was like the late 70s, this version was built. This particular version of the spec was defined. It was incorrect. And as an industry, things get a bit muddled. So just be completely clear. We're talking about should you be able to do something, not who are you in that model. So when does authorization become a problem? And I think the best way to kind of see this and demonstrate this as hopefully an audience of developers or people that have built software is let's go and scale a company, let's go and scale a product and figure out when does authorization need to change and evolve and at what point. So early days, I refer to them as like the blissful day of roles, when you got some system and you allow users to authenticate, they're given a role. And in your application code, to basically enforce what that user can do, you can just go and whack in a nice little if statement. So if the user's email contains the company's domain, you're an admin, great, you can do everything. If not, you can't do certain things. Very simple if statement. You can sprinkle it across every request handler that's inside of your system and all good. If you want to be a bit fancier, maybe you can look for a scope inside of a JWT and those sort of things. But the logic is pretty simple at this point. So now we kind of evolve a bit. We fast forwarded. We've got like a product out there. We reached a point where we actually start, selling it to the market. Let's say, and we have a sales team who want to go and package up different features in different ways so they could, have a good, better, best type pricing model, which is very kind of common. And so now you need to start enforcing restrictions and access controls based on which version of the product you have. Very common thing. So you might then go into that system into your code base and augment it, and now go, right, if you have the email address of our company domain, you can access it, or if you've got the premium package. So you imagine there's this like database that stores which companies this user belongs to and which package they have, and you can go and augment that if statement. You might want to go and use a feature flag system. It's a bit of a misuse of feature flags if you ask me, but there's certain tools that kind of allow you to do this segmentation of users. But ultimately, you have to have this logic sprinkled across the code base again. Let's go a bit further. It's like, cool, you're now really successful in one part of the world. You want to scale up, and we're now, unfortunately, in a world where, or fortunately, depending on your things, where data locality and data regionality and restrictions become a problem or a concern. Your system needs to implement and control. So now let's say you need to split your data between Europe and the US because you have GDPR in Europe, and then you have like things like CCPA in California. There's others around other parts of the world, China, Russia, etc. So now you need to start putting further checks in here, which is, okay, is your access granted based on your email, what package you have, also what region of the world you are and which region your company is based in, for example. So you now need to do further checks for every single call into your system to grant access based upon that. And you can maybe use the scope for this. There's kind of language and library specific and framework specific systems like Castle or Can that can kind of start doing this. And then you evolve a bit further and you're now in the big leagues and you're selling to enterprise, and you want to go through that setup. And this is something I've been through in a few businesses now where, we had a pretty solid system. We had sort of an admin role, a manager role, a viewer role, an editor role. And we kind of got pretty far with that. But then we started working with proper enterprise with a capital E style companies who have tens, if not hundreds of thousands of employees. And now suddenly you need to be able to support their organizational structure inside of your system, because you can't give 10,000 employees the same role. You need to be able to represent departments and regions and reporting lines and cost centers inside of your permission, even though it's the system you're building, not something internal to them. So you might go down the route of like, let's set up user groups and then give roles to groups. So this if statement gets a bit more complex. So now we're checking the domain, we're checking the package, we're checking if someone's in a group, we're checking what region of the world the request comes in to, etc. This is kind of traditionally your directory style information. So LDAP, Active Directory, these kind of technologies can store this user hierarchy in groups and memberships, etc. You got through that, you got this complex kind of permissioning model. Now you want to kind of get past all the RFPs and the security questionnaires that you inevitably get as you start selling to those types of businesses. And so a way to shortcut a lot of that is just to go and get your compliance certs. So your ISO 27001s, your SOC 2s. And with that, there's a load of requirements around access controls and permissions that you need to have in place. And one of those is around audit logs. So not only being able to demonstrate you have access controls, but also demonstrate the log trail that's generated from them, which if you were to implement it yourself, you now have to go and put in these extra logging lines and capture the decisions of who's allowed what across the different parts of the code base. You can maybe use some sort of logging library for this. And then at some point in your journey, there'll be the inevitable discussion of like, do we do microservices, or do we move from a monolith to a microservice, or the inverse, which seems now to be the thing of going from lots of microservices to a modular monolith. Your platform and your architecture ultimately is going to, at some point, evolve and change over time, which now means this authorization logic, that big if-else statement that you've had to sort of develop over time, if you start moving to heterogeneous microservices, your main platform's in Go, but you're doing some AI LLM stuff in Python, but you need to have authorization there as well. You now need to re-implement this logic into n number of languages. And every time those requirements changed, you're going to have to go and rewrite and remodify and basically duplicate that logic in n number of different languages, which is going to be kind of prone to error and such. So you've done all this, you kind of got through it. Now let's do some AI stuff. And this is where we kind of run into what does authorization look like in a world where you need to be able to have the system that essentially can access data and give you response to prompts and chats based upon it. So the answer to this is by externalizing your authorization. But before I go on to that, let's go and look at what a typical RAG architecture is. So RAG is a retrieval augmented generation. And there are multiple components, which we'll go through here, that bring it all together. So the reason why RAG architectures exist is it's kind of not really possible today with the context window sizes we have to load all your data into one massive context window and let one of these models go and produce an answer based on your input, based on the full data set you have. So what businesses are doing and what systems are doing to do this is loading the full data set into some sort of vector store. And this is going through an embedding model, which basically takes data in whatever form it is, be it a PDF, a website, a code file, a documentation of some sort, and vectorizes it. And by vectors, it basically turns it into a numerical representation. And that's stored in some sort of vector database, of which there are many out there now that could be used. And that's basically an efficient way of storing that data and allows you to do queries that find like related documents, related bits of resources based on the inputs that you've done. So you've had this large data set, which ultimately is your source of truth. It's got everything in it. It effectively has like root access to some degree to your internal data sets. It could be your CRM system, it could be an ERP system, it could be your own internal knowledge base, but it stores everything in it. And what the kind of typical integrations we see today is you have some user, they ask a question of the system, like what are the total number of the expenses in our expenses tracking system come to? And so that's the user's question. You can imagine it in a chat style interface here. That question then goes through an embedding model to vectorize that information. And then the vector database is queried to find, okay, go and find the documents inside of your storage which are related to this question or have some similarity to this question. So in this case, with that question was asked about going the expenses, the vector store query would ultimately go and fetch all the expenses that it knows about and returns them down. Those responses are returned, injected into the prompt, and we'll go through a live demo of this in a second. The prompt then goes off to the LLM. The LLM will then come up with some sort of answer and then return that back, and it'll say things something like, "Here, the total of your expenses is $7,000." Let's say. So that's the flow we're going to go through. But now we're going to go through this step by step and then talk about how and where authorization is required.
What's the acronym RAG? You said it, but it was fast. Retrieval Augmented Generation?
Yep, exactly.
Okay.
Because you're augmenting the generation of what the LLM spits out with information that you're giving the prompt. And that'll look a lot more obvious when I pull up what these prompts look like.
Okay, awesome. We have a couple of questions in chat, but they're all assuming knowledge of RAG. So Vijay, I see you, but we'll bring those up later after we get over the basics. Yeah.
Absolutely. So the problem with this architecture, and I kind of hinted at it there, is your vector database, the augmented generation piece, is going to have access to all data. And there's no awareness and there's no context of who you are in terms of what data you should access. And this is where authorization becomes a real problem. So if you imagine like an enterprise organization, you could have someone in a team in Europe asking questions about your financial data or your sales, and they're getting answers that are based on data that exists maybe in your US office. And that should not happen. So you need to start looking at, okay, how can you authorize and filter and control that black box today, ultimately, with a view of who the person making the request is. And this is where something like Cerbos or other kind of authorization systems can help you. So we're just going to jump out of that and come into a little demo application we have, which demonstrates each part of this particular process. So this is a very basic sort of database. In it, we have some expenses that have been created by different users. So we have Sally, who has an expense of $300,000 for NASA. We have Ian, who has another expense of $1,000. Each of these belong to a region. They have some status associated with it. Some of them might be approved. And we could go and add kind of more expenses in here. This would be in your regular old database, Postgres or whatever, if you were building this application. There's nothing really fancy or AI about this yet. It's simply just the records inside of your system. So the first step that goes through, if you were to go and build one of these systems out, is you need to take these documents and vectorize them and store them inside of a system. So what does actually vectorizing look like? Ultimately, you give a embedding model some context. So I could say like, hello, CNCF. It will take that, you say, go off and embed it, and then it will go and vectorize it. And this is what hello, CNCF looks like once you embed it or vectorize it, which is a big old list of numbers, which represents this data, but numerically in such a way that these models can compare and contrast and rationalize over the data. So what you need to do for kind of structured data, we need to take those records. So we can see here, those are the different expenses we saw earlier. I'll take this one for like NASA. And we basically structure it as like a mini document. There are lots of ways of doing this, lots of approaches to do it. Some keep it in the original format, some structure it as documents. But ultimately, you're taking the data in that particular record that's in your database, and you vectorize it. So we can run that one, and I'm sure you can spot the difference here. Maybe not. We've now vectorized it. We now have an embedded version of that. The embedding model I'm using behind the scenes here is one from OpenAI. I'm all running it locally in my machine though, so I'm using Olama as the runtime for that. So there's no like paying for cloud service or anything like that. It's all running locally in my machine. You need a beefy machine to some degree, but we're running this all locally, and now we're actually embedding the documents. So the next step is to store these embedded documents into some sort of vector store, which allows you to then do the querying around, go and find me the related or similar documents based on this kind of input. So locally on this machine, I'm running an open source vector store called Chroma, and there are many out there now. Postgres is a PG vector extension now, which does be able to store embeddings. But ultimately, if I load what's in the vector store on my machine, there's one record in our vector store, or one document in our vector store that for each record that's inside of my sort of application database. So I've got each resource ID, I've got the embedded version of the document, and then I've attached metadata to it. So vector stores allow you to ultimately just store the embedding, store that big object or that big list of numbers, but you can also annotate and attach metadata to those records. So in this case, I've actually attached metadata to each document that contains the pertinent information that might need for making authorization decisions. So I now know there's metadata field here that tells me who the owner of it is. There's metadata that tells me which region this particular expense belongs to, approved by, etc. And this is going to become important later when we want to talk about how we handle authorization with this. So we have our vector store, we loaded data into it, and now we actually want to go and put in some place some kind of authorization around it or some sort of access controls around it. Because we want to avoid the scenario where someone in one part of the world can run a query and get a response back based on data they shouldn't have access to. And this is where Cerbos comes in. So Cerbos is a complete open source project. You can go and grab it on GitHub, and we'll put the link up in a minute. And it's a policy decision point and a policy language. So in the world of like authorization, the standard approach is you have some sort of policy decision point. There's a policy loaded into it, and then different services can call that policy decision point and ask for either a permission check. So can this user do this action on this resource, or it can return basically a filter or a kind of like a where clause that allows you to filter down your data based upon the conditions or the checks that are inside of your policy. So what we're looking at the screen here is just one of what we call our Cerberus playground. Just give it a refresh because I've updated it. This is our Cerberus playground. Ultimately, the way Cerberus works itself, it's just a binary, a container that you run locally, and then you load into it policies. In Cerberus's world, policies are just YAML files. So anyone that's happy with Kubernetes and CRDs and those sort of things, this will probably look very familiar. And what the policies do is they define the rules and the access controls and the logic that needs to be met for certain actions to be allowed or denied. So in this UI, we can see on the right here, we have some example principles and resources, and we can see which actions should be allowed. So based on your logic. And in the middle, we have the actual policy itself. Clean this up a bit, make it a bit bigger. So we're working with this idea of an expenses tracking system, and we have some business rules and authorization logic behind it around who can do what inside of it. So this Cerberus policy that we're looking at is a resource policy. So we're defining a policy for the resource type of expense. There we go, resource kind of expense. And then we have different rules. And each one of these rules is defining for the given action under which condition that action should either be allowed or denied. And in the world of authorization, you might have heard the terms of RBAC or ABAC, or role-based access control and attribute-based access control. And with a Cerberus policy, you define exactly that. So as a very simple example, which we'd never recommend in production, is you might have a wildcard rule that says all actions should be allowed if the user making the request has the role of admin. Very broad, sweeping permission check, but it's a very good example of a very simple role-based check, where all you're doing is looking at the role a user has and then deciding, cool, if that user has the admin role, then they can do everything. Where things get a bit more sort of interesting / realistic is when you're starting to do checks based on actual data. So in the world of Cerberus and how Cerberus policies work, then we defining for each of the different actions, we're defining what role user must have and then under which conditions. So here we have the action to view, so who can look at a resource, and we have a few different rules that define the logic behind here. So we're saying to view a resource, an expense, you're allowed to see it if you're the owner of the expense, and we'll come on to this in a second. If you're a manager of the region the expense belongs to, or you're a manager in the finance team. And we'll also say if you are allowed to view an expense, if you're in the finance team, but not a manager, then you're allowed to view it as long as the expense is less than $100,000, because you want, only a manager can approve very big expenses. So how this is structured here, the YAML structure defines kind of, there's a schema behind it, how you structure it, and then these conditions or expressions are defined in something called Cell, which is Common Expression Language. It's another open source project from Google, which we use inside of Cerberus. It's also used heavily in Kubernetes. And a Cell basically lets us define the conditional checks and the logic that we want to perform at request time on a particular action. So what this condition is saying is for the inbound request, for the particular resource, the amount attribute associated with it should be less than 100,000 for this action to be allowed. So internally, when Cerberus evaluates it, we're looking at the request that comes into Cerberus. And what I'm pulling up here on the right is kind of the inbound request. We say, here's this user, it's ID Derek, he's got the roles of user and manager, his department is finance, and his region is in EMEA. And the particular expense he's accessing, or they're accessing, is an expense, a kind of expense, got an ID, and there's some attributes about it, amount, status, etc. And then based on that logic, so this is a $500 expense, Derek here is allowed to view. We can see that going on. If I go and drop this down to, say, just 100, then the logic will update. He actually owns this one, so that won't update. But the rules are basically defined here around who can access. That's why, because I'm on the wrong person. Apologies. Here we go. So you can't access it. If I drop this down to 100, then the permission will update based on what this rule says. And, the beauty of doing live demos.
We promised to break things up top, so
Oh, yeah.
you're keeping me
There we go. You
honest.
can see it switched over now.
There we go.
So the logic basically is defining the access controls around it. So this is all very well and good when in the case where you know who user is, you know the actual resource they're trying to access, and should that access be allowed or denied. Where things get tricky is where we no longer know necessarily the individual resources that user trying to access, but we want to filter down access to all the records in the database based on the context and based on who the user is and their roles and these rules. And this is where Cerbos has a capability called query plans or plan resources API, which allows you to basically say to Cerbos, I have this user, they got these teams, groups, roles, departments, etc. They're trying to do some action on a kind of resource. So we're not saying for this concrete expense, but we're saying what actions can they do across all the expenses inside of the system. And in this case, Cerbos doesn't give you back an allow or deny. It gives you back something that we call a query plan. So let me show you what that looks like. So for a query plan, you have to give Cerbos who the user is. So we're going to go and pretend to be someone called Ian here, who has the role of admin. If you remember in our policy, we had a rule that says if you're an admin, you can always do everything. So we're going to go and fetch the query plan. So this is doing a live call in real time to the policy behind the scenes. On the left-hand side, we have the request. So we said, cool, Ian, he's got the admin role, he's in the IT department. He's trying to view the expense resource. The action is just view. And what Cerbos says back to you is, cool, based on your policies, Ian should actually always have access. So there's no filter, there's no rules you need to put in place. Ian should be able to go and access everything everywhere. Now, if we go and be someone, so take that Frank user who's in the finance team, and now we run it this time, now we are actually getting a response that says, okay, this is the conditions here. So behind the scenes, we've gone and evaluated as many of those policies as we can, and we've reduced the condition set or the conditionals down to the smallest set of possible conditions that must be met for the particular action to be allowed. So in this case, for Frank in the finance team, in order for him to view an expense, we have an or of these two conditions. So either the owner ID is equal to Frank, because we have a rule that says you're allowed to see an expense if you own it, or the amount of it is less than $100,000 in this case. So this is fully dynamic. I could actually go and update this logic. And then I could go and rerun this. Live demo time. There we go. That number's now changed to 200,000. So this abstract syntax tree of conditions, which is kind of what the data structure is behind the scenes, is generic. And thus you can use it to filter a regular SQL database with a where clause. You could use it to filter, apply as a Mongo filter. You could use it as you could convert it into like a query parameter on some API call you make. It's very agnostic and generic, and it can be applied to any sort of data filtering. Hopefully you can now see where we're going with this. Mm-hmm. So we have our underlying data. We have our business rules, our authorization logic defined as policy. We've put all the data into a vector store. We've attached metadata to the documents in our vector store. And now we actually want to start prompting it and asking questions. And this is where the final part comes in, which is like, we have this chat bot to chat with our expenses system, because that's always something everyone wants to spend their Friday night chatting to. So I'm going to pretend to be Ian, our admin person. I'm going to say, hey, list all the expenses. Just keep it at that for now. And we're not going to do any sort of filtering. We're just going to go and say, cool, chatbot, off you go. So behind the scenes, back to that diagram, request comes in. We are going out to the vector store. We're fetching all the relevant vectors based on the question. We are then going and injecting that into the prompt. We're sending that prompt, which has that context in it, off to an LLM using Llama behind the scenes for this, again, or locally. The prompt, the model then, based on the prompt, gives back an answer, and we get the details back. And so here we actually have the data that we saw back in the resources section that is in our vector store of all the different resources. And then just to show you what's going on behind the scenes. So we're running this without any authorization checks. There's no query plan. There's no filter being applied. And the actual full prompt contains, you're an assistant, question answering tasks. You've been asked, your following piece of information has been retrieved as context. And we've actually got those objects that we saw originally there in the vector store injected in here. So the prompt now has further context in it based on underlying data. We also give it some further context, like who the person made the request is, its ID, roles, etc., the current time, and then some kind of business logic. And then the LLM has spat out an answer which is based on that. So we've augmented the generation of the answer to the question using the data from the vector store.
Fascinating.
Cool. And I could go and be sort of someone else. Let's go and be Sally. So Sally is in the EMEA sales team, and list expenses, we kind of get the same response. So now let's go back to our original problem, which is how can I make sure that you're only getting answers in your chatbot or your response or your agent based upon the actual person making the request? Because every time I change my user here, I'm going to get a different response. I'm going to get an answer. I should get an answer relevant to who I am and what's going on. So if I ask this currently now as Frank, who's that finance person, we get the same response and we can see there's no filters. So I'm going to just turn on the checkbox, which applies authorization. So how this works, this diagram we saw before. So request comes in, this is my prompt. The question comes in, it gets embedded. It goes off to the vector store to go and fetch the relevant documents associated with it using that embedding. It's injected into the prompt and off we go. Now with authorization, we're essentially injecting Cerbos into that process. So the request comes in, we embed the model. We then say to Cerbos, okay, what conditions do I need to apply based upon who this particular user is to return just the documents in the store that this person should have access to. So therefore, the documents that come out, get put into the prompt, are the ones that this person only should have access to. Then it goes off to the LLM to actually parse it and come up with a decision, come up with a response, and then outputs it back. So this one above here, we have Frank. Without authorization, there's no query plan, there's no filter, and the prompt is everything in it. If I now go and send the request with authorization turned on, if I didn't break the policy, you can now see we have a slightly different response. We are missing the $300,000 one. And if we look at the details behind the scene, Cerbos in its query plan has returned back, stretched a bit, has returned back a query plan which says, okay, for this person, there are conditions. They should be the owner or the amount should be less than 200,000. We've converted that into a metadata filter. So every vector store has a slightly different way of doing metadata filtering. And this is the particular syntax that Chroma DB uses. So all we've done is basically map that data structure into the system specs. So again, we have an or, and we're saying the owner ID attribute must be equal to Frank, or the amount field must be less than 200,000. And then the actual prompt that's then gone off to the LLM to come up with a decision now has only the documents from the vector store that are relevant. And we're getting a different answer, which is now contextually aware of who the user is. We're doing all the pre-filtering. It's all dynamic. So we could go and change that policy behind the scene. On the next chat prompt, we're going to filter that down even further, and we're going to apply the latest and greatest policy, which means ultimately, as a business or an organization, as a security team, as a data science team, you can define what your access logic should be once, centrally, as policy files. Both your application and your AI systems can use that single source of truth, that single definition of who should do what, which helps you loads for compliance. It helps you loads for testing. It helps you loads from auditing as well. And then you can be assured that the conversations or the agents that are running inside your business or inside your application are aware and actually enforce what your business requirements around when it comes to authorization, without you having to hard code a lot of logic and having to do loads of manual sort of output and augmentation of results. And that ultimately is what we're going to talk about. And actually, there's some questions coming in, so happy to take those.
Yeah, this has been absolutely amazing. What a great, well thought out story. I was riveted the whole time. All right, we have lots of questions. How critical are resource-aware, policy-based cluster schedulers for managing the complex demands of LLM and RAG deployments across multiple Kubernetes clusters?
Oh, that is a great question, and I'm wildly underqualified to answer it, but I'll give you my best shot. For these models to be performant, you are going to have to make sure they're running on nodes or clusters of nodes, which have good enough hardware ultimately. So your scheduler needs to make sure that it goes and puts the actual inference model on a machine that has a sizable GPU or a TPU or something like that. If you do want to fully self-host it, obviously there's lots of managed services out there that are willing to run this all for you. It's always going to be a trade-off. Like, do you want to commit to get that hardware in there and pay for a big heavy cluster, which may not be used all the time, versus just hitting an API? But yeah, you're going to very much have to be careful around the memory constraints, particularly, and hardware constraints ultimately, of what is going on, and making sure your scheduler is putting them on the right node, and also just making sure that the components that don't need that resource aren't scheduled on that node, because you don't want to be wasting space on a particular node in your cluster with some service that doesn't need the specialized hardware that can just run on a commodity compute node somewhere. And then making sure that your actual inference models are on machines with the right hardware. Where you store a vector store as well is something to consider, because you really want as much of that in memory as possible for performance, but that doesn't need like a TPU. So yeah, when it comes to your cluster design and your scheduler definitions and taints and those sort of things, just be very cognizant of which nodes have the right hardware to run an inference model, and making sure your scheduler doesn't put other things on that, because you want to give as much power to these LLMs as possible, so you get a decent token per second, which is the metric people talk about a lot.
So we're talking the word's policy based. Where does the policy sit? Does it sit closer to the vector database, or does it sit closer to the user?
So when it comes to the policies behind authorization logic, and the policies, the literal policy files themselves can kind of sit anywhere. With Cerbos, we recommend just store them as another asset in a Git repo. The bit you need to make sure is collated sensibly is the policy decision point. So the actual Cerbos container that's running. Authorization is in the blocking path of every request. On a simple API check without all the fancy RAG stuff, your request comes in, it's authenticated, you need to authorize that request and then make a decision. You don't want to add any more latency than you need to. So making sure that your policy decision points are distributed across your application in a sensible way. Cerbos itself is fairly stateless, so there's no other external dependencies, there's no database or anything like that required. So you can horizontally scale it. And actually in Kubernetes, we recommend running it as a sidecar. So inside of a pod, you would have your chat agent, your chat application system, and then right as a sidecar, you have Cerbos, so it can go and fetch those very quickly without going outside of the pod or off the node. Cerbos itself will always respond sub-millisecond. Anything else beyond that is network time. And then we have a question about sidecars.
Yeah. I think, did you answer it? I believe you did, about best practices around sidecars in Cerbos.
Yeah. So obviously everything's always a trade-off. If you want the best performance possible in the way Cerbos is architected, sidecars are always going to be best. If you're worried about the overhead of that, firstly, Cerbos is perfectly fine with like 128 megs of RAM and 0.1 CPU. It's very, very light on resources. If you want to go maybe a bit further from that, you could do like a daemon set. So there's at least one Cerbos instance running in every node in your cluster. But you could just run it as one central service and let Kubernetes manage and route to it. But just think about every network hop that's involved beyond the application to Cerbos is going to add a small bit of latency. The multi-cloud environment or clusters across cloud or on-prem, this is a use case we see Cerbos being used for quite a lot. Because Cerbos doesn't have to maintain any state, you can just put Cerbos across every environment. That sidecar model means it does it without even thinking. Same with daemon sets. But yeah, thinking about where you locate your Cerbos instance relative to your application, and then making sure your application can talk to the services it needs in a performant way, particularly if it's going off to another node that has the LLM running on it.
We still have some questions, but I want to say we have a lot of, this is very cool. And nice presentation, both of which I agree with totally. Here's a question. Can I use the login information from Cerbos to customize the prompt for my LLM?
Good question. So let me jump back to here. So what you can do with Cerbos, the identity information, that login information, that user profile information is kind of a required bit of data you have to give Cerbos. So if I switch back actually to a better example, so this object is essentially like the user profile, the principal information that you give Cerbos, saying I'm this person. The structure of this object is you need some sort of ID, you need some sort of list of roles that a user has, which are usually stored in your IDP or a directory system, and then you have this attribute map, and it is just a map. You can put whatever fields in here that are relevant. So you could augment this and put in attributes of what teams or groups or roles, teams, groups, or business units this user belongs to. You could put in attributes about their location in the world. You can use things like IP address, those sort of things. And as soon as those attributes are passed to Cerbos, in your policy, you can make use of any one of those attributes to make an authorization decision. And anything in your policy then gets reflected in the query plan. So that filter that we saw here would start referencing, if your policy is referencing those attributes, which then would then get mapped into a filter, which then goes down to the LLM. So any attribute that you have about your user, and in theory, any attribute you and any attributes you have about the individual resource they're trying to access, is fair game to write a policy around. And then due to the kind of the workflow we ran through, that then gets applied to the filtering that gets applied to the vector store, which then gets used in the prompt, which then goes off to the LLM. So you can kind of do full journey. Any attribute about users or resources can flow all the way down and influence the decision and influence the conversation if you're going with a chatbot, or influence the output of an agent.
So cool. So what are the key advantages for self-hosting production level LLM and RAG models on Kubernetes compared to relying on public APIs?
Well, advantage is you own everything. We're not having to rely on some third-party service. It's not simple. It's not trivial to do it, as we kind of outlined previously. You do need a pretty hefty budget as well to get the compute nodes and such that can run these things performantly.
I like performantly.
Yeah, let's go with that one. So if you're going to go true production, I would go and look at what, not necessarily OpenAI, Gemini, etc., but look at what the hyperscalers can provide you. So in Azure, inside of Google Cloud, inside of AWS, they have these models that are still semi in your environment. They're essentially like inside of your VPC rather than hitting like the public API. But if you do want to go down the fully self-hosted route, you definitely can do it. From just from my own time building out this demo and such, Alarm is a great way of just spinning things up locally. But there's definitely whole operators out there now built around Kubernetes to spin things up efficiently. But it really just comes down to time and money.
As always. Such is life, yeah. We have one more question right now. Anyone out there, if you have any questions, now's the chance to ask. Otherwise, this is our last one. So in real-world production scenarios, is self-hosting LLM and RAG models on Kubernetes generally... Oh, wait, I already asked that.
It's the same question, but I'll slightly differently. Same answer applies.
Okay, same question. Okay, never mind. There's not even one more. All right. Well, I think that's a wrap. Is there anything you'd like to say in closing, Alex?
I would just say when you start, it's all very easy to get carried away in the bit of the hype train around, LLMs and AI and everything. If you're seriously thinking about going to production with these sort of things, don't forget about the security side of things. It's all very well giving this magical experience, but if it's not secure, if you're starting to, breach data locality laws, etc., you can get into a lot of trouble very quickly. And I would also recommend not building those kind of systems yourself. There's lots of open source projects like Cerbos that can help you with this. And you can find out more at cerbos.dev, and links are in the chat. You can also scan that QR code to find me.
Oh, and one more question came in during the. Is that okay?
Mm-hmm.
With Cerbos playing the role of gatekeeper in the RAG workflow, will we be rolling out the red carpet for gRPC to handle these policy checks, or should we stick with classic HTTP for smoother conversations with Kubernetes?
So Cerbos itself is built on top of gRPC, and most of the Kubernetes APIs are as well. The reason we did that, though, wasn't because we just wanted to try it. We've had lots of experience previously, as in me and the rest of the team, of building low latency, high performance systems. gRPC is a much more performant way of communicating between services than sort of heavy HTTP REST style approaches. We won't go into the minutiae of binary encoding and wire encoding right now. But if you're really lasered in on performance and latency as some of your key metrics and what your SLIs and SLOs are, gRPC is the way we always recommend. It also gives you nice things, being able to code gen SDKs and those sort of things from the protobuf definitions.
Amazing. Thank you so much, Alex, for sharing your time and expertise with us today. It's been an absolute joy. Thank you. Goodbye. Bye. Oh, wait, I have a closing script I'm supposed to read. Here we go. Let's do the thing. Thanks, everyone, for joining today's episode of Cloud Native Live. It was great to have Alex Olivier here with us to teach us about implementing robust authorization and RAG-based AI systems. I have a much better idea of what I just said than I did when I did this 45 minutes ago.
Mission achieved, accomplished.
I really love the interaction with Alex. You answered the questions. Thanks everyone who asked questions and had nice things to say. I guess even if you had mean things to say, thanks for interacting. Here at Cloud Native Live, we bring you the latest in Cloud Native code on Tuesdays and Wednesdays and sometimes Thursdays at this time, which is noon US Eastern.